Okay, this is a video helping us out with the meaning of logarithms and some logarithm properties. This is going to be the beginning of helping us be able to solve equations with exponential and logarithmic expressions inside of these equations and trying to be able to isolate variables even if they're in the exponent of an equation. So here we go. Just a couple of basic things first. What I want to show you is right away the meaning of logs, in the sense that, remember, we talked about a logarithm was the inverse of an exponential. And so this is how we can convert from an exponential equation into a logarithmic equation. So notice where the bases go. A is the large number in the exponential, and A is the number below the surface in a logarithmic. Notice that the exponent B for the exponential, it becomes isolated in a logarithmic, and what a to the b would be equal to, c, becomes part of the log expression in a logarithmic. So you need to be able to go forwards and backwards here. So if it's in exponentials, you need to be able to write it as a log. If it's in a log, you need to be able to write it as an exponential equation. All right, so let's do a couple of those examples together so we can see how it works. All right, so if I wanted to write my log base 6 of 36 equals 2 as an exponential form, keep in mind that my base is 6, so that's going to be my large number, and then the exponent is the one that's isolated. 2 equals 36. All right, so doing it one more time, the base 289 is now my large number. The exponent is what is isolated, 1/2, and it's equal to the other piece of my log, 17. So again, you need to be able to go forwards and backwards. So now let's do some logs into exponential form. So the number that I identify right away is what the base is, 64. So log of 64. And then remember that from my previous examples, the exponent is what gets isolated in a log. So that is going to end up being out here, 1/2, the exponent, and then what it's equal to is part of my log. So log base 64 of 8 is 1/2. Now what does that mean? So that means that 64 to the 1/2 power is 8. That's what that means, and that's kind of how I go back and forth between the exponential and the logarithmic. All right, one more time. My base is going to be 12, so log base 12. The exponent is what's getting isolated, and what I'm equal to, 144, is now part of my log. All right, now I'm going to rewrite something with some variables just so we can see kind of more of a general situation. Again, my base grabs my attention instantly, so I'm going to go with u to the v power, because v is my exponent because it's isolated, equals the other piece of my log, 15 over 16. All right, and then if I'm in log with a bunch of variables, I could still do that. The base is u, so log base u, and then v is what I was equal to, and my exponent got isolated. So that's how it just continues to work with my forwards and backwards, exponents into logs, logs into exponents. Make sure you're paying attention where the base goes, where the exponent goes. All right, doing some more with just the rewriting. Now it gets me into evaluating. Remember, evaluate literally means, notice there's no variables here, it literally means give me a number, a numerical answer. So I want to find out what log base 4 of 64 is equal to. Not exactly something that a lot of calculators can do. Keep in mind that this means 4 to some power equals 64. That's what that means. If I'm just using my a to the b equals c and converting that to log base a of c equals b, using that same pattern from exponential to log, log to exponential, 21 here is this same setup. So now what you would do using your calculator or just using your own trial and error system, 4 to what power is 64? So 4 to the first, no, that's 4. 4 to the second, no, that's 16. 4 to the third, there's your 64. So this would be 3. And that's how you evaluate any of these scenarios. So if I do another one of these, something like number 22, that's going to be 6 to some power equals 216. So I'm going to leave that for you to try, but I'm looking for what do I raise 6 to. So 6 to what power is going to be 216. So I'll let you try that one on your own. All right, simplify each expression. We're actually not going to do that, so forget that I talked about that. All right, so that's some of our practice converting from exponents to logs and logs to exponents. Okay, so now what I've got to talk about is some logarithmic laws. If you want to just pause your screen and write down some of these things, I've also made a Google Doc of this available on your website, just so you could have a quick reference to all these laws. So these are just ways to simplify logarithmic expressions, and we want to make sure that we understand the relationship between what's going on. So product, if we're taking the log base b of m times n, so if I'm multiplying inside of a log, that's the same thing as adding the individual logs. So if I'm multiplying logs, that's the same as adding individual logs. Okay, if I'm taking a ratio or dividing within my log, I can subtract the two individual logs. If I'm raising a log to a power, that's the same as multiplying log base b of n to that power. My roots here, whatever the root is that I'm taking, so here would be the q root of n, that's the same as multiplying by the inverse, or 1 over q, times my log base b of n. And then a change of base, so moving from that base to another base, moving from base b to something else. If you just take a look here, log base b of n is, and log base a of n times log base b of a. So this is a way for me to change bases with still keeping the same value. All right, so I'm going to do a few of these and just keep kind of going back and forth and referencing how we would use these to simplify some of our expressions. So properties of logs, we'll do a couple of these to help us out. So this is log, and when I don't have a number here, that means it's log base 10. So, I'm not going to keep doing that, but it's just a reminder whenever you see a log and then a blank base, that's a log base 10. Your calculator does log base 10, so we really like log base 10, again, because we can use that calculator to help us out. So this, just keep in mind, is the same thing as the log of 6 plus the log of 11, keeping in mind this is log base 10. All right, so the product is the sum of the two individual parts. All right, moving to number 3, division makes me think subtraction, and that 5 makes me think coefficient that I'm going to multiply by. So this is going to be log, well, my exponent's going to end up going out front, so 5 times, and then I'm going to have the difference of the two logs, so log of 6 minus log of 11. As if I just go back as a quick refresher of my laws here, I had a power rule right here, so n to the p was the same as p times the log of n, and then I had a ratio here where I divided inside my log, which was the difference. Notice it was numerator minus denominator. So if I go back to my properties, you could see a little bit better where that came from. Notice my directions are just to expand, so I'm just writing out in long form what the simplified expressions are. And I just continue to kind of work through some of these properties. Number 5, I've got a exponent in addition to a ratio inside of my log. So that's going to give me the 4, that 4 is going to be only attached to my first log, log of 2, and then I subtract my other log, log of 5. All right. Now that's different from number 6, where everybody is raised to the 6th power. So that's the 6 out front, and then it's the difference of the logs inside. So again, make sure you see the difference between number 4 and number 6, or sorry, number 5 and number 6, so you can understand when everything is raised to the 6th, everybody is multiplied by the 6th. But when only this 2 was raised to the 4, only the log of 2 was multiplied by 4, not both pieces. All right, moving down a little bit further where we've got a little more, some complicated stuff. How we go down to 11? 11, we've got a radical or a cube root, and we've got some products. So a real quick refresher of the law. All right, so with my roots, remember whatever the root is, that becomes the multiplying by that inverse out front. And then remember my products becomes adding. So going back to my properties of practice, everything is going to be multiplied by 1/3 because of the cube root. And then inside of here, I'm just going to I'm going to add each individual log because I'm multiplying. So log of x plus log of y plus log of z. And hopefully you can see how that works there. Now we could go backwards. So if we're paying attention, number 13, this is asking us to condense. So that means that I want to take the long form, like what I just created, and then go backwards to a more simplified version of it. So subtraction makes me think division. So log of 3/8. Again, notice that because that base is blank, it's still blank down here, but that's still log base 10. Now that's a little bit different from something like number 15, where the 4 out front makes me think of an exponent for, and since it's the 4 on both, you can almost see this as 4 times log 3 minus log 8, which then indicates that this is going to be 4 times log, and then it's going to be a ratio 3/8. There I go. That's how I'm going to use that. Okay. Now just working through a couple more things here to make sure that I'm picking up the clues that they're giving me. Like something in number 18, 2 times the log of 7 over 3. Well, I almost need you to see this as 2/3 times log of 7. So that 2/3 is going to remind me that I'm going to have an exponent of 2, as I should have done in 15. My last step here should have been log of 3/8 all raised to the 4th power. So that would have been finishing off 15 correctly. So I'm going to do something similar with this 2/3 here. So I've got log of 7, and all of that is raised to the 2/3 power to deal with what I multiplied by. All right, something like number 19, the addition makes me think of multiplication. The 6s out front make me think of exponents. So first I'm gonna factor out that 6 log base 3 of u plus log base 3 of v. Now, a really important thing to point out is on all of these examples that I've been doing, the logs have had common bases. If they don't have common bases, these properties are out the window. So we want to make sure that we're focusing on the logs and the properties of common bases. All right, so now the addition makes me think of multiplication. So I still got my coefficient of 6 out front, and then I can condense into 1 log of u times v. And then finally, that 6 out front is going to be an exponent. So our final answer would be log base 3 of uv to the 6th power.